it looks like we have a bunch of folks on, and I wanted to thank you, Ruby, for doing this webinar. Folks, this is our second in the series of the Third Coast Augmented Intelligence for Health Bowl seminar series, and the first one was with Ryan House, where you learned everything about, the regulatory landscape and all the data that is going to be available to you. And most of that data is going to be available via APIs. And so we thought, this would be a good follow-up to that, to have a workshop that talks about API fundamentals with Ruby. And I'm joined here today as well by Eva. Unfortunately, I have to drop halfway through the webinar, and then Eva will take the Q&A after, halfway through. So any questions that folks have, please use the Q&A in order to ask those questions, and Ruby will be kind of monitoring those and answering them as we go. And so with that, I'm going to turn it over to you, Ruby, to start off.
Fantastic. So hello, everyone. I'm stoked to be hosting a webinar on APIs for you all. And my hope is that you're kind of able to take some cool learnings out of this introductory session and apply it to your next project. We'll be looking at some absolute basics when it comes to APIs, and we'll get to tinker around in Postman as well. No prior knowledge about APIs is needed for this session. The skills that you gain today are guaranteed to help anyone along in their journey here. But while we're here, it looks like Nan just mentioned this as well. I know a ton of questions are going to be coming to mind, as this topic is kind of tricky to wrap our heads around. So if you're not quite grasping things, that's okay and totally normal. If things feel a little flaky today, no worries. You can always take our Postman Student Expert training at your own pace for free anytime. But if you do have questions for me, I'm sure there is a way in this webinar to gather them. It sounds like there's a Q&A box. I'm planning on jumping into those right after this session to answer any questions that come up. Please do not shy away from sharing your questions. I want to make sure that everyone leaves the session more confident about the topics that we're covering. I do want to give you a quick heads up that I'll have questions for you throughout as well, and you can share response to those in the chat. We'll get a chance to use Postman to follow along, but to do that, you'll need to sign up for a free Postman account if you haven't done so already. You don't need to download the desktop app, but you're free to do that if you want. The browser agent of Postman is going to work just fine for our purposes today. If you choose not to follow along, that's all right too. This session, I heard, is going to be recorded, so you can choose to follow along later and maybe just watch for now. But with that, let's jump in. I'll start by introducing myself. My name is Ruby, my pronouns are she and her, and I'm a senior developer advocate at Postman, which is a platform that millions of folks use to work with APIs. I haven't always been in the tech space, though. I was previously an elementary and early ed school teacher. A series of very fortunate events, supportive people, the choice to graduate from a coding boot camp, and a whole lot of hard work led me to where I am today, which for the most part has involved continuing to find ways to spread knowledge. Here's a snapshot of what we'll be covering today. By the end of this session, you should be able to explain why API education is important, explain what an API is to your postman or woman or them, explain what goes with APIs behind the scenes, so how servers and clients relate to one another, and how to make API requests and analyze their responses. Then we'll also have a follow-along portion so you can test out an API in Postman. Like I mentioned earlier, I'm going to do my best to carve out space for a Q&A at the end of the session. You can ask me questions about the content that we covered today. And just as a reminder, I'm here as a resource for you all, so let's just get started. So first, what is the deal with API education? Why should I care about being educated on APIs? And what's Postman student programs got to do with any of this? To illustrate why API education is a big deal, I've added a GIF here from a powerful and meme-worthy moment in history when Steve Ballmer from Microsoft was playing up the importance of developers. I've added it because, for the most part, developers are the ones who care a lot about APIs, but they're certainly not the only ones who should. I've also linked some study findings in here in which survey respondents were all API users. What the study reveals is that lots of different roles benefit from standardized data access provided by APIs. Folks in management, solutions architects, business and data analysts, educators and researchers, et cetera, et cetera, et cetera. Most professionals are going to need to access real data at some point in their careers. Whether they know it or not, they'll be tapping into APIs to accomplish a lot of that. And Postman is what makes it easy to speed up those API interactions. So because of Postman's helpful features around APIs, the tools become kind of an industry standard used by many top companies, as you can see here, as well as individual developers. If you're learning about Postman, you're already ahead of the curve because employers at most companies are looking for folks who can easily use and understand tools like Postman. There's over 20 million folks already using Postman, so chances are pretty high that you're going to need to interact with it at some point on your journey as you work alongside tech professionals. So we'll be diving into the nitty-gritty of what APIs are and how you can use one to supercharge your application or applications. But as a heads up, a lot of what we'll be discussing is covered in detail in Postman Student Expert Training. That training is self-paced, hands-on, and free. And it's something that you can always revisit as much as you need. Plus, you get a nifty certificate and a badge when you complete the training, which you can always throw on your social profiles. I'd even venture to say that if today's workshop feels a little over your head, or maybe you want to understand APIs a little more deeply, then completing the expert training is really going to set you up for success with these more complex projects that you all are working on for the Health Bowl. Here's a quick pulse check. Having had little or no background from me yet on what exactly is an API, which of these services do you think involves APIs? Is it A, an application's login or sign-up flow where you can use authentication from another source? Is it B, adding songs to a playlist in an application like Spotify? Is it C, closing out your online shopping cart on a website? Or is it D, receiving a text message confirmation from a website? Feel free to throw your guess into the chat here. So while folks are thinking on that one, we got A, B, C, D, we got E, all of the above. Interesting. So that was a little bit of an unfair trick question. The truth is that APIs really are everywhere. So the answer is all of the above, if that's what you were guessing. They're responsible for allowing code in one corner of the internet to talk to code in another corner of the internet. So the million-dollar question here, right? What is an API? API stands for Application Programming Interface. APIs are considered to be the building blocks of modern software. Like we said before, APIs allow code to talk to code. So you can picture an API as a contract or an agreement between code sources. APIs are what let Cindy Lou's homemade weather app use information stored on some server containing weather data. That real data is exposed through an API, a contract that Cindy follows in her application in order to collect the information that she needs. Sometimes, like Cindy, we need to get data from a service, like Google, Facebook, or Twitter, as some examples. Since we don't have access to those companies' code bases, they create APIs so that developers can get information from their services without access to the code base. Both developers and non-developers use APIs to get data from popular services to use in their own projects. So let's see an API in action. I'm going to show you two Postman collections, each with different related requests within them. One will be using a messaging API to send myself a reminder of an upcoming medical appointment. The other is going to be an API that allows me to see the interactions between two drugs. I won't dive into the inner workings of them just yet, but I'd love to show you quickly how easy it is to use Postman to get access to this kind of data through APIs. So I'm going to tab over to where I have a workspace set up. And in my workspace, I have a couple of collections. Each collection has related requests inside of it. So first, I'm going to actually check out my Twilio messaging SMS API here. Once I open that up, I have a folder and a couple of requests in here. I'm actually going to send myself a message from this request. So this is post send an SMS. To send this request, and this is all based on the documentation from Twilio, I actually need an account SID in my parameters. I also need a phone number that I'll be using. This is a fake Google phone number that I've created just for this demo. and a Twilio phone number. This is assigned to you once you sign up for a Twilio account, as well as the message that you want to send to yourself. So the message I'll be sending to myself is, hey, you have an appointment with not Dr. Mario, let's say Dr. Zoidberg. Hopefully that's how you spell his name. So really quickly, here's my Google Voice phone number. Here's a message history. You can see that I've done this a few times in the past. Previously, it was Dr. Mario, so you should see a new message coming in here pretty soon. So I've got a reminder for an appointment coming up with Dr. Zoidberg. Sending that request. I can see, looks like I got a CORS error here. Interesting. If I save it, send it again. Interesting. So this is happening. I wonder if because I sent too many requests earlier before this demo. That's all right. I'll try the other API here for now, but you can see with the messaging API, aside from that CORS error, I can have the ability to send myself a text message, which is very convenient. If you're building applications for medical appointment reminders, this would be a helpful one for you to check out. But otherwise, here is the RxNav API. There's a couple of different requests in here, all within different folders. The drug interactions API has the ability for you to get interactions between a list of different drugs and the interactions for one specific drug. Here's an example flow of how you would use this drug interaction API. Just as a background, you can also use the RxNorm API to get the specific identifiers for each drug, which will be handy. You'll see in this last request because you're going to need those identifiers to compare those drugs. So in this example flow, first I'm getting diflucan's, diflucan's RxCUI, unique identifier. So if I send this, I get the identifier for diflucan. I can always just copy that because I'll need it in that last request. I also want to get Zocor's unique identifier. So if I send this, I get this identifier, copy that. Then in my last request here, where I'm actually seeing the interactions between these two drugs, I can copy this into my query parameter here as a value. So both of these drugs, diflucan and Zocor, are added here. If I send this, then I get a JSON body or an object here in my response object with the different interaction data. This is all in JSON format right now, like I mentioned very quickly. That's JavaScript object notation, and it can be kind of a lot to read. One thing you can do in Postman is set up a script in your request area over here in your test tab. And you can set up a template actually. So if you wanted to visualize this data that you got back in a different format instead of JSON like this, which can be hard to read, you can set up a script which is using HTML and handlebars templating under the hood. And that allows you to actually visualize this in a table, which is a little bit easier to read. So I'm able to actually go into this section here, into the interaction area, and see, these must be other names for those drugs, see the interaction between them. Looks like there's not any information about the severity here, but there is some description of what could be going on. Here's another interaction data set on the same drugs. Looks like here there is evidence of high severity and some extra description for you that might be helpful. Awesome. So without diving into the nitty-gritty of what went on behind the scenes, let's actually take a step back and think about what was going on. So on the surface, we just saw me seeing interactions between two different drugs, but there was quite a bit of action going on under the hood. To have been able to get that information, I needed to access RxNav's API. And I was able to access it by following its contract, which is all documented in their docs or documentation online. But what's the real 1-2 step here on a very high level? We can imagine APIs as data liaisons through a popular analogy people like to use to conceptualize APIs. We can think of an API as a waiter at a restaurant. Imagine you're going to your favorite restaurant and you want to order something. You, in that case, would be a client, You're sending a request through the waiter who tells the kitchen what to make. The staff in the kitchen processes, gathers ingredients, and prepares your order according to specifications. The waiter's going to come back with your food, or they may come back to tell you that the kitchen is out of the thing that you ordered. Regardless, the waiter serves as kind of a liaison between you and the kitchen so that you in the front of the restaurant never have to know what goes on in the back. And that's what APIs do for clients and services. You're the client in this case. Maybe you're using a browser to go to some website. On that website, you make some choices to pull up some information or change information, maybe even create something new on the website, like a new user. And the API is what handles your request to do these things. The API is not going to bestow itself to you on the website as some physical entity. It exists as just a simplified concept, like the waiter, written in code somewhere that the user cannot see. It'll reach out to where the data that you want lives on the server. So thinking about the client in that restaurant analogy, the client in our restaurant was you, walking in and making your order. The client is the agent that's making a request. A client could be a browser or an application that you've coded. It could even be your command line on your computer. It's the thing that makes a request to a server. If I'm using Postman to make requests, Postman would be the client because it allows me to make requests and view responses from servers. A server controls resources and services. An API is that interface that exposes these resources and services to clients over a network, like the public internet. Requests and responses are like a call and response that are sent over a network to some server. The client can interact with an API by making requests over a network through that API. The API then evaluates the requests, performs any required operations, maybe interacts with a database or other APIs, and then sends back a response from the server to the client. So this is all great information about requests and responses and how they happen over a network between a client and a server with the help of an API, but what goes into a request? Before jumping into that, I mentioned some apps and services that have APIs we've all probably used. Can you think of some APIs that you've come across in your day-to-day? The way that I like to think of it is, did I visit an app or a website that had to store, fetch, or otherwise manipulate data for me? If you have, you can share that in the chat. I know I've definitely used my Google login to sign into a bunch of random applications. Those applications used Google's API to allow that kind of authentication to happen. Maybe you've used Stripe's payment processing API to buy the latest Jordans online, for example. There's tons of possibilities there. Looks like I got a heads up that it could be because I'm missing the desktop agent for that messaging API. So when we jump into the demo afterward, I'll try it again from the desktop agent, see if that works. Great tip. Looks like Miriam used a database to access scientific journal articles. Awesome. Great. So now that we've talked about what an API is, let's talk about requesting and receiving data with one. Here is what you would find in a request. We'll get a chance to look at what goes into a response pretty soon, but let's first focus on requests, the thing that a client first shares with an API. So methods, when you see them, they look a lot like verbs. They describe what an API is going to do with your request. The endpoint or path defines where the API should do those actions. Those two parts of the anatomy are the bare minimum needed to send a request. The others are going to be based on your use case and how detailed you need to be when sending a request. You would know more about that based on the documentation for that API, and we'll take a closer look at those in just a second. So taking a look at methods and endpoints in requests, when you make a request to an API, you're specifying what you want to get out of that interaction with an HTTP method. Methods, like we mentioned, are verbs. They're actions. They let the client know which action to use for that URL. Again, the client can be anything that you're using to make requests, like curl on your command line, an app that you've developed, your browser, or Postman. There's a lot of methods out there, but the ones most commonly used are get, post, put, and delete. These correlate or map to operations like CRUD, which stands for create, read, update, and delete, which you might have heard of already if you have a little bit of a development background. If you think about a healthcare app where a user can enter the name of 2 drugs and see the interactions between them, that user is making a GET request to retrieve that information or read it. An API goes ahead and delivers your request to the server where the data lives and returns the response, which is hopefully exactly what you requested. This happens so fast, you could blink and you'd miss the transfer. When you try to add drugs into the system, you're attempting a post request. You're creating new data on the drug interaction data servers. If you were trying to delete drugs from the servers, you'd be attempting a delete request. Of course, publicly accessible APIs like the Drug Interaction API are going to require you to be authorized to make certain kinds of requests. Otherwise, the server would contain all kinds of random, possibly incorrect drug data. Let's talk about put versus patch for a quick second, because even in this table, they share the same definition. Patch is for updating partial data of a record while keeping other data, whereas put requests are designed to completely overwrite the existing data for a record. Lots of folks get put and patch confused or use them interchangeably. So if it's not immediately clear what the difference is, that's totally normal. But in addition to a method, an API request is also going to require an endpoint. An endpoint includes a URL with a path. In addition to methods and endpoints, requests also have the ability to include parameters. When you make an API call with a GET method, it's usually going to retrieve everything from the URL address. This could be pretty overwhelming. Parameters specify or zoom in to the response data so that you can get only the specific information you're looking for. And they're not always going to be needed in every request. You can always confirm what's needed for a request to an API by reading that API's documentation. When we were making our request to the Drug Interaction API, we could have gotten every interaction under the sun, but we entered some extra information in our request to help us focus on just what we needed and only get that information back in a response. That extra information was in our query parameters. So let's see what that looks like again in Postman. So let me just minimize this so it doesn't confuse us. This was that final request that we sent to find interactions between these 2 drugs that we specified. So if I check that params tab here within my request and request world up here, you can see that I have query parameters. And this was actually from the documentation for this API. They required us to enter RxCUIS, or the unique identifiers for those drugs that we want to check their interactions. So this was required. I entered the values in this exact syntax that they suggested in their API documentation. And this is an example of how you would have used query parameters in your request. In addition to query parameters, you'd also sometimes have path parameters. Path parameters come directly after a /. They, in this request, would look like, well, this is our root API endpoint. After that, we have /rest /interaction /list.json. That is the path on our endpoint here. Sometimes you might have to add extra path parameters like IDs. So for example, if you go to twitter.com, in the URL, you can see / and then your Twitter handle or Twitter ID up there. That's an example of a path parameter. In addition to query parameters, requests also have headers. Headers provide additional metadata about the request to the server. Metadata is data about data. Basically, headers can be thought of as the information that you would see on the outside of an envelope. There's still a message being sent within the envelope, but the outside of the envelope is going to tell you information about what you'd find inside. For example, a return address or a fragile label. Headers are important for authorization. which allows clients to access protected resources from an API. In fact, it's common practice to send some authorization data like access tokens in the header. Twitter's API, like I mentioned earlier, would require authorization, for example, because if it didn't, anyone using the API could be able to post on my behalf or maybe even search private user information, which would not be ideal. And if you can't remember what each of these headers are, don't worry, you can hover over tooltips in Postman to learn more about them at any time. A quick note about headers, they can also be sent back to the client by the server in a response. So if we look back at our request here, we have other tabs we can explore in Request World. So in addition to parameters, we can see headers. And we have some auto-generated ones. If I send this again, maybe it'll show. Could also be because I'm a little too zoomed in. Maybe not. Let's see with this request down here. Usually there are some hidden parameter or headers here. So one example of headers, I'm using this post request here, is the content type. So this is letting the server know what kind of content is coming their way. So when you send this request, this is data about the data you're sending. So that's one example. Oh, and if you, let's see. Oh, that's fine. Let's see if we can find another example later on. Great, so that's headers. If you wanted more background on headers, there's also this TikTok video available for you in this presentation, which hopefully will be shared out with you later on, so you can check that out whenever you want. So in addition to parameters, endpoints, and paths, headers, we have request bodies. When you're interacting with a website or an application, you're not always just going to be retrieving information or making GET requests. There's going to be times when you need to add or change data that you find in an application. We talked earlier about other HTTP methods like post, put, and patch. For these methods to be used, your API is going to expect you to send something new with your request. This is going to be sent through a request body. A body could also be sent to the client by the server in a response. You'll often see the body in JSON format. This stands for JavaScript Object Notation, but it's not necessarily JavaScript. It's just an easy way to organize data in a readable format. So we saw earlier with this request that we sent that our response actually came back in JavaScript, in JSON. So this is just the format that we saw it in. You can also send a request body. And yep, there's that heads up that I should be using the desktop agent for certain requests. But in the request body, you can also select JSON as the format that you're sending that information. In addition to JSON, there's other formats that you can set. So if you were sending form data, you can specify that as well. Great, so we just went over the anatomy of a request. What is the bare minimum needed to send a request? Let's see if folks remember. What was the bare minimum needed to send a request? While folks are thinking on that, let me see if I can actually change my agent here. It's asking me to download for some reason. I'll pull it up here. And I happen to already have this up. Quick question for Ava. Are you able to see my application here for Postman without any lag? Okay, great.
It's kind of in front of the other application.
Okay, but there's no like visual lag with it?
No.
Okay, great. So what I was hoping to show here earlier, great, there it is. With the headers, you get tooltips. These are auto-generated headers. You can always check out what they mean by hovering over them here in the desktop app. And previously, we were checking out request bodies. So with our interactions API, we have the option if we needed to send data actually, this one is a good one because this is a post request and we're definitely sending data with a post request. Our body can include form data. So in this example, this is form data, and we needed the body, a to and a from for this to send to that server. Great. So it looks like in the chat, someone has shared get. So the method is definitely one of the things that's considered a bare minimum to send a request. In addition to that, you also need an endpoint and a path. So methods and endpoints with a path are the bare minimum. Awesome. So let's check out the anatomy of a response. When you send an API call or a request, you're going to receive a response. There's a ton of great information that you'll get back in the response body, like status codes, response headers, and a response body. We also see things like latency, which if you're in QA, quality assurance, or otherwise just testing out an API, this could be helpful information to track performance. So one thing that really stands out with responses is that they include status codes. You don't see that in requests. So checking out what we had in Postman here, if I were to send, actually I can try this out again. I'll send this again, and this time it was successful. And I got a new message about Dr. Zoidberg. Let me just double check. Yep. So in our, sorry for flipping around so much. In our application here, we have request world. We also have response world. This is where we're focusing now. So you can see in my response here, when I was sending an SMS message to myself through Twilio's API, I got a response body, and I can see that in a couple of different ways. It looks like it came back automatically in JSON format. I also see this status code. I can hover over it to get more details in Postman. I see latency information to see how different parts of the response or how long they took. I can see the size of the response, all kinds of great information. Looks like there's also headers in my response, just like there were headers in my request. Awesome. So APIs return status codes with every response. 200 OK means successful. Other common examples are like 201 created, 400 bad request, 401 unauthorized, 403 forbidden, and 404 not found. You've probably seen a 404 error before. If I mistype the URL for a website like rudy.com instead of ruby.com, I might get a 404 status code and an error message if no such website exists. If you take one thing away from this slide, just know that anytime you see 200s or 200 level status codes, they are generally a success code. 300s would be a redirect, meaning that you were trying to do something somewhere that actually should be happening somewhere else. So you'll get that kind of status code, a 300 level one. 400s are client-side errors, meaning that the API was expecting something, but you might have made an error in what you sent it. So potentially like an incorrect URL or in a parameter formatted in a way that was not expected. And you would be able to double check that by checking the API documentation. You might also get 500 level errors. 500s are server-side errors. So like in the case of a DOS attack, DOS, denial of service attack, you'll often see a 500 level error. This usually happens because of poor rate controls set for the server, but that's usually on the server side. You don't have to memorize these status codes. Again, Postman's going to explain the codes to you, and if that's not enough, you can always check out status cats. Yep, status cats. I've added a link to status cats here in case you're curious. Basically, status cats are memes for each of the different status codes, and the memes involve cats. So if that's what you're into and that's how you learn, that's there for you to check out later. And then here's another TikTok video for you to check out if you want on status codes. Great, so I've done a lot of talking so far. Let's get our hands dirty and test out an API for ourselves. We saw some APIs in action earlier, but let's actually try all of the CRUD actions available to us in another API. Hint, this is the follow along portion, so if you want to dive in with me, you are welcome to. I'm going to show you how I go through the homepage in Postman, and you can follow along with me to find the Postman Library v2 API. So I'm actually going to see how much I can accomplish in my browser using the browser agent here. I go back to home. So if you are following along, you would sign into your Postman account and you would come across a home screen similar to this. You should have a workspace called My Workspace, which you can work out of for this example. I have another workspace that I created that I'll be working out of. But up here in the search bar, you want to search for Postman Library API v2 or some combination of those words. And the first option that you'll get as a result is the Postman Library API v2. Looks like it was created by Postman, and it's a public workspace. So that seems official enough. I'll click that. And from here, you can see that there is a collection available to you. If you click it, you see the documentation on how to use this API and this collection. A couple of caveats and things for you to remember here. I've already read this thoroughly. Of course, I encourage everyone to read this thoroughly, but it looks like you're going to need an API key to be able to authorize yourself to make certain requests, the post, patch, and delete requests specifically. So that's going to be important to remember. However, where I am right now in this workspace, even though it's a public workspace, I can't actually send any requests because I'm not allowed to, I'm not a collaborator in this workspace. There's a padlock on this collection letting me know that this is just read only. That's all right because I happen to have a workspace where I can create a fork into. So what that means is if I go to the More Actions menu on this collection, and I select Create a Fork, Postman's going to allow me to make a copy of this collection in a different workspace where I do have permissions to play around with it. So because this is a fork, I'll always be maintaining an association with the original collection. I can call it whatever I want, but you have the ability to keep the default that's assigned to your fork. And you can select the workspace that you'll be working out of. I happen to already have a fork of this collection, so I'm not going to fork it again, but you can select My Workspace if you're following along, create the fork, and Postman's going to transport you to that workspace. In your case, it would be My Workspace. I'm actually going to navigate to the workspace where I already have a fork, and that's here. So here's my fork up here. I can select it again. I've got all of the same documentation. I have all of the information about the caveats and some extra information about stuff I should be careful about because this is a public API. Please be respectful, modify books that you've added yourself, understand that any books can be deleted. And right up top, you can see that this API helps you manage books in the Postman library. It's designed to teach the basics of APIs and Postman. And it looks like there are books that have a property called is permanent collection set to true. So those books cannot be edited or deleted. So great things to know. But the biggest standout thing is that there is an API key I'm going to need to use to authorize myself. So I'm going to copy this. And at this collection level, it looks like I have the ability to change variables. In my documentation, it says that I need to set my collection variable to Postman rules. So let me go here. And I see API key here. I'm going to actually paste Postman rules here. Close out that documentation, save this. And now I should be able to send some requests. So when I open up the collection, I have a folder available to me called Books. In there, I have some requests that I can send and another subfolder called ID. And in that folder, I can edit specific books based on their ID. So let me actually start by getting all of the books that are available in this library. Let's see. So there's that reminder to use the desktop agent. No worries, I can do that here as well. So here's that same collection. And I get books. Hopefully, actually, let me see if I set my variable to, yes, I did. It's already saved. Awesome. So I'm going to go back to get books here, send this request. And it looks like I can see every single book that's available in the library. Looks like each book has its own unique ID, year published, checked out, and is permanent collection with a created at timestamp. So this is interesting. Each and every book has the same properties, and some of them are actually different from the other books. So this one has checked out to true. This one has checked out to false. Interesting. So now that I've seen every book in the library, I'm actually noticing that there's a book that's missing that I would like to add to this library. So I can make a post request by going into post, add a book. And I can, because it's a post request, the API is expecting me to send a body with this request. So I'm going to go into the body tab here. And it looks like I can add a book with a title, an author, a genre, and its year published properties. So I'm actually going to add the Very Busy Spider to the library. That was written by Eric Carle. That's not a self-help book. That is a fiction book. And it was published in 1984, I believe. Great. So I'm going to save my request. Then I'm going to send it. And in my response, you can see that I got a response body, which includes an ID for this new book that I created. You can notice that I didn't actually come up with that ID myself. That was auto-generated. The title, author, genre, and year published that I added are here. Checked out is automatically set to false. Is permanent collection is automatically set to false. And created at has this timestamp auto-generated. In addition to this information in my response body, I also have a status code for that request. It looks like it's sent successfully, and I got a response 201 created, which specifically means that I tried to create some data on the server, and I was successful in doing that. Great. So that's a 200 level status code. I also got some extra information that we get with responses. Awesome. Let's say, for example, that I actually want to check out this book. It's not checked out right now, so that means it's available. I'm going to take the ID of this book, copy it, and I'm going to take that ID into this ID folder where I can start fiddling with individual books. In this case, I want to work with this individual book that I just created. I'm going to go into the patch update a book by ID request here. And I'm going to remove the ID that's here by default because that's not the book that I'm working with. I'm working with the one I just created. So I'm going to paste that in there, save it. And since this is a patch request, the API is expecting me to update some information. So it's expecting me to send a body as well. So if I go into the body tab here, looks like I can change checked out to true, which is exactly what I want to do. So I'm going to leave that as it is and send the request. Looks like checked out was set to true. I got a 200 OK success message. Awesome. Now let's say this book actually is lost. I checked it out. I lost it. So now I can't go back to the library for somebody else to check out later. It's gone forever, unfortunately. So I'm going to take that ID and I'm going to go to the delete request here. And kind of the same situation. You take that ID and you replace it. You add it here where there's ID, take away the default. Now this is a delete request. The API is not actually expecting you to send a body for a delete request. It just needs the ID to work with. So I'm going to save this and we'll see what's unique about delete requests once I send it. So I'll send it. And what's interesting here is that I got a 200 level success code, 204 no content specifically, but I didn't get anything in my response body. That's actually what I would hope to see. So if I'm deleting something from the server, I want to see that it isn't there anymore. So I shouldn't see any response body for that thing that I deleted. 204 no content, if I hover over it, it lets me know the server successfully processed the request, but is not returning any content. That's good news for me, actually. So what if I tried to delete this book again? Now I've deleted it once, meaning it's gone forever. I shouldn't be able to delete something that doesn't exist anymore. So let's see what happens if I try to delete it again. This time I got a 400 level error, meaning I got a client-side error. That means I made a whoops. I was trying to delete something that doesn't exist. Here's the message. Book with this ID, not found. That's kind of what I was expecting as well. I can't delete something that's already been deleted. It's already gone. So this is, in this case specifically, a good status code. Awesome. So going back into where we're at here, before I jump into that one. We just did some CRUD actions if you were following along with that library API. We created, read, updated, and deleted data on using an API. So we were able to use different HTTP methods to be able to accomplish that. And we got hands-on with an API that you're able to use. It's publicly available. So that's great. And a lot of people actually wonder what they can do with the stuff that they're doing in Postman. So if you'd like to use what you've been able to do in Postman in your own application's code, so for example, let's say that you're building out an API for your own app and you need to test what you've built in Postman, you could generate code in a number of different languages to copy and paste right into your code editor, like VS Code, or into your terminal as well. So in our library API example, I'll actually go back into the app here. If I look at get books, this was great. We got to send this and see the response that we got back from the server. That's great for testing. But let's say this is something that I love and I want to put it right into my application's code. How would I do that from Postman? If you scroll all the way to the right, there's this code icon. And from here, you can actually select the language that you want this code to be in for this request. In my case, maybe I want JavaScript fetch because that's the code that my application's in. I can actually just copy this right into my code editor for my project. I can also, if I wanted to do this in curl, do that there as well. So let me actually see what that looks like. This should work on my command line. If I go into my terminal and just paste in the code I got from Postman, I should see all of the books in the Postman library, just like I did here in the Postman app. And it looks like I am able to do that. So I see every single book that's in the Postman library right now. Of course, this is curl. It's on my command line, so it looks like a giant wall of text, which can be very hard to read. It's obviously a lot easier when you have something a little more user-friendly, like the Postman application, to see the response in. Awesome. So that is the code generator tool that we have available to you as well. So recapping really quickly, what did we explore here? We got a background on API education and Postman student programs. We checked out what exactly is an API, and we got to see behind the scenes what goes on with APIs. So clients and servers and the request response pattern. We also took a look at the anatomies of requests and responses, and we tried some CRUD actions out using the Postman Library v2 API. Here's some resources for you all. There's some general Postman resources, which most people find helpful, plus one that you might find specifically helpful for your projects. There's the Learning Center or Postman Docs linked here. You can find more information there about how to visualize the data that you get back in responses, how to use mock servers, how to use the code generation feature, etc. There's also the API network. That's where you can find many more public APIs to explore. There's a community forum, and that's where folks go to share what they're working on. You can also find information about upcoming Postman events and more. Then that last resource on the bottom is the National Library of Medicine. They have a few APIs that you can experiment with, including the RX norm and drug interaction APIs, which you saw me tinkering around with earlier. Of course, there's lots of other examples out on the web, but if you were curious about the ones that you saw today, the link is here for you to explore. This is the link to the Student Expert Program. The invite code should be pre-populated for you all when you use the link, but I've added it here just in case you need it. Again, this slide deck should be available to you right after the presentation. This is where our Postman student community is super active on Discord. We're always on our server sharing fun projects, news about hackathons, sharing memes, all kinds of fun stuff. So if you're looking for a community with us, you could find it there. Also, if you're working on your projects and you stumble across some unique challenges in Postman or with any particular API, you can always connect with us directly in that Discord community and we can help unblock you. We're on Discord 24/7 and especially eager to help you folks in particular as you're building out some important real world solutions. And then this is our classroom program for educators who want an API curriculum to share with their students. We offer a free license to our product for educators, so it's a pretty sweet situation for any teachers that might be interested. And then these are a couple of cool, free, publicly available APIs that you can play around with. Some of these might even have a place in your future personal projects. So feel free to start up a collection in Postman and check the docs for these APIs to construct requests with their parameters and anything else that's needed. Big thank you to you all for joining today's session to talk APIs with me. If you're looking for more learning content on APIs or generally just curious about the stuff that me and my team are working on, we are all people of the internet and have our own socials that you can follow. Feel free to give a shout about how the session went and I'll make sure to connect with you. One parting question for you all to think on is what APIs do you want to explore? Great, so I'm open for Q&A and here's that quick link for the API training if you wanted to get your hands on that as well.
Thank you so much, Ruby. That was a fantastic presentation. I learned a lot. I think probably the teams learned a lot as well. Thank you so much. If anyone has any questions, please type them into the Q&A and we will answer them. We do have a question from Miriam. She says, this is very cool, meaning the Postman app that you were showing. Should we want to keep using Postman? Is there a premium version that we would need to pay for eventually?
That's a fantastic question. So Postman is free for everyone, up to 3. So if let's say you're working on a group project and there's 3 of you can be working on the same team on the same account in Postman for free. But if you wanted a 4th member, that's when you would start having to pay for more, for higher level tiers of Postman. But that's all available at postman.com. There's actually a page that outlines what you get with each of our tiers and how many folks you can have on your team. So if you want to check that out, feel free to find that information as well.
Great, thanks so much.